solving polynomials again, and you're going to be looking at doing it by factoring. There's other ways to do it, but in this particular lesson, we're looking at different types of factoring, a particular factor by grouping. Your experience with factor by grouping is extremely limited. And I can't say with 100% certainty, but I'll use a 95% certainty that your grouping is going to occur for you guys in this class and the homework on the test, with the first two being grouped together and the last two being grouped together. I don't think that there are any exceptions to that. So, although there could be, there should be, I just don't think there are. When you have 4 or more terms and you want to factor, what you try to do is look at grouping them with the first 2 terms in one group and the second 2 terms in another group. Now, technically, we're still adding those 2 parentheses. It's not a product. That's not what I'm implying. But because this is a negative third term, the negative has to stay with that 4. When you do that, in the first binomial, what's in common? X squared. So we will factor out an x squared. And when you do that, you'd be left with x plus 5. Now, I will tell you without exception, if your third term is negative, like this one, you have to factor out a negative. So whatever it is that's common in this binomial, you need to say, not only am I going to factor out what's in common, but I want to make sure I take the negative also. So what else is in common besides the negative? 4. And when you factor out negative 4, you're going to be left with a positive x. And what else? A positive 5. If you're going to be successful in factor by grouping, the binomials that are left have to be identical. And they are in this case. So now you're back to taking something out that's in common. You have the 2x plus 5s that are in common. We factor those out. And what are we left with? X squared minus 4. And we're still going to be equal to 0. How does x squared minus 4 factor? So x plus 5, x plus 2, and x minus 2. So what does x equal? Negative 5, negative 2, and 2. How many roots are there? We know right from the get-go that we should be finding 3 roots. And here they are. Yep.
So on a problem like that, you don't need to write it.
It can't be in ordered pair because we only have one variable.
Okay. Oh.
And the question is solved.
Okay.
So again, that's a really good question. How do you know what your answer should look like? This is a solve. We want to know what value of x makes this true. These are the 3 values of x. Definitely not an ordered pair. It's just 3 different x values. Now, if we were looking at f of x equals this polynomial, these would be x-intercepts. And then if I was asking you what are the roots or the x-intercepts, you would put them as comma zeros. Your graph would have x-intercepts at negative 5, negative 2, and 2. They would all be single roots. Leading coefficients positive, so it would do your positive s.
Okay.
Not what they're asking, though. Not on this problem. Okay? Everyone follow this factor by grouping? Okay? Visually, this is what we're doing. When you group the first 2, you have stuff here. Second 2, what you're trying to figure out is, in these parentheses, what do they have in common? You're saying that there's a triangle in both of these. We're going to take the triangle out. It's a product plus a product. So we're going to take the triangle out, and you'd be left with the circle and whatever that rectangular type thing. Okay? And if you look at it, well, if you have this as your product in the second spot, The x plus 2's are in common. You're taking the x plus 2 and moving it to the front, and you're left with x plus 5 plus x plus 7. I'm not trying to make things more convoluted. People get confused once they wrap things in parentheses. The x plus 2 is what's in common. That comes to the front. You're left with x plus 5 plus x plus 7. All right? Like I said, in this class, in your class, when you have 4 or more terms in your factoring, first 2, last 2. This is a trinomial. But the trinomial is technically in quadratic form. How do you know? So did the first one. That equals 0, too. Yeah, you got an A, B, and a C there. But how do you know it's going to be in quadratic form? There's a giveaway. Well, that's quadratic form. AX squared plus BX plus C.
The second one's half of the first one.
The second what?
The x squared is half of the first one.
So what's half?
X squared is half of the first one.
Specifically, I want you to say the word. The exponent. The middle power is half of the first power. That's how you know. If you had a 6 and a 3, good to go. 10 and a 5, good to go. 10 and a 4, not so much. If the power in the middle is half the power of the leading term, you're, bless you, quadratic form. Okay. There are 2 ways to handle quadratic form. And I don't know that I'm going to tell you to do one over the other. If you recognize quadratic form, you can just factor it and everything works out great. If the power of 4 and the power of 2 really messes with you, this is the other option. So I'm going to do it both ways. I don't think I have it both ways. Is that the same problem? Different problem. Good. So we'll do it 2 different ways. This one. Right here. One way is to say, look, this power stuff is confusing me, so let's let Z equal x squared. Just go to the land of make-believe. You're in charge. Let Z equal x squared. Remember, we're going to be solving for x, though. If Z is equal to x squared, how can I rewrite this with Z's? 2Z squared minus Z minus 3 equals 0. This is right in your comfort zone. Everybody's comfortable factoring this. So you go ahead, and however it is that you factor, it doesn't matter to me how you factor it. We'll get to that point. So Z is going to equal 3 over 2, and Z is going to equal negative 1. Everybody with me? But we don't care about Z, do we? What do we care about?
X.
X. And what is Z equal to?
X squared.
X squared. So x squared equals 3 over 2. And x squared equals negative 1. If you square root both sides, x is going to equal plus or minus the square root of 3 over 2. Please don't leave your answer like that. It's not an acceptable answer. What do you have to do? You got to rationalize the bottom, so we multiply by root 2 over root 2. So you're going to get x is equal to plus or minus the square root of 6 over 2. In the other case, what is x going to equal?
I.
Plus or minus I. Right? When you square root, don't forget, add that plus or minus. So the values of x that are going to give you solutions, you have 2 imaginaries and 2 reals. Everybody okay with that? this way works great, and it allows you not to have to worry about this power of 4 and this power of 2, and get back to something that's just right quadratic, easy, no problem. But if you recognize quadratic, and you're comfortable with quadratic, and you say, oh, I'm in quadratic form, you're going to just ignore the powers, and just realize that when you factor this, that instead of putting 2x here, you're going to put whatever the middle terms is, 2x squared in x squared. And then it's going to be 3 in 1, and it's minus and plus. So you're not doing really anything different other than the fact that you have to recognize that this is x squared, this and this are x squared. Just like when we switched to z squared at the first, and because this is a z, we have z and z. It's the same concept, just with a higher power. So then we take the 2x squared minus 3 and set it equal to 0, and we get right down to x squared equals 3/2. The same thing we got down at the bottom of the left side. And over here, x squared plus 1 equals 0, and x squared equals negative 1. So x equals plus or minus I, x equals plus or minus square root of 3/2. So root 6 over 2 and plus or minus I. Now I think, and I could be wrong, but I think there's at least one person in here saying, how come he's not reducing the 6 and the 2? Why aren't we reducing the root 6 over 2? Because the 2 is not under the radical. So this is what we get for no, make that sense. Is everyone following? Everyone with me? This works with any situation where the power of the first term is double the power of the second term. Try this one. Whichever way you want. So it's not recording now, it's recording. So magically, x squared minus 4 and x squared plus 1 just appeared. So x squared minus 4 equals 0, x equals plus or minus 2. X squared plus 1 equals 0, x equals plus or minus I. Can we graph this?
No.
Why not?
It's not
Not a function. These are not ordered pairs. This is not a function. This is just an equation we're just solving. Short assignment. Okay? What I would encourage you to do is look into the calendar for next week at the chapter review stuff and start spinning yourself back for this test. Now, I need about 10-15 minutes of which you can use that time to do this assignment, and then I can get you your quizzes back. I do need to resolve that issue.